All right, this is a video of the 2019 AP Calculus official practice exam. This is first one is number one, and we've got a table. Now, only part C is really one that you need to worry about for the 2020 test. But I'm going to go ahead and go through all the parts real quick just to tell you why something wouldn't be on the 2020 test. So part A, you could have to do one like part A on the 2020 test, but you wouldn't have a function this difficult. So you've got a table, and it says it's about cars entering and leaving a parking lot. So they enter at this equation, 30 plus 5 times t minus 2 times t minus 5 times e to the minus 0.2t. And then they leave with this table right here, okay? And it's from 0 to 12 hours. So what's the rate of change of e of t at time t equals 7? And we've got to indicate units. So what you would do, since this is the calculator portion of the, if you were taking a normal AP Calculus test, if you want rate of change, you've got to take the derivative. So you would find e prime of 7. Okay, so in the 2020 test, they would give you they could absolutely ask you one like this, but they would give you an easier function to take the derivative of by hand. You could take the derivative of this. You would probably do 5t minus 10, so you would distribute the 5, and then you distribute the e to the minus 0.2t times t, and then times negative 5. It would be a pretty hard derivative to take by hand, but you could do it, and then you would have to plug in 7. But this question was meant to be done on your calculator. So if you were using a calculator this year that could do calculus, you would get 6.164 for the answer. All right, but again, this one type of one could be on the test. Just they're going to give you an easier derivative to take. What are the units? Now this is something, a rate of change. So you've got the unit for L of t divided by the unit for t. So it's going to be cars per hour per hour. Okay, you can write it that way, all right, or you could just write it cars per hour squared, okay, to get your physics involved. Okay, so rate of change means derivative. All right, let's take a look at part B. Now, part B would not be on there. It's too bad because it's easy. It says how many cars enter the parking lot from time t equals 0 to t equals 12, and you know, you would just integrate from 0 to 12 of e of t dt, and that would be just a calculator problem. So you would have to plug all this into your calculator, but the calculator would do all the work. But this kind of problem where you're integrating, accumulating things, and you're solving the accumulation of something through integrating is not on the 2020 test. Okay, finding a rate of change it just wouldn't be this hard. Having to get the right units would be. This is not on the test. All right, part C, though, absolutely could be on the test. So it's good to practice a trapezoidal sum. So I'm going to erase this part. So it says use a trapezoidal sum with 4 subintervals indicated by the data in the table. Okay, so we're wanting to figure out from 2 to 12 of L of t dt, and we're going to use a trapezoidal sum. So it's just the base times the average height. So we've got 4 intervals. There's interval 1. 5 to 9 is interval 2. 9 to 11 is interval 3. 11 to 12 is interval 4. So our first base is from 2 to 5. So that's a base of 3. The average height would be 15 plus 40 over 2. Now, will they give you like one like this on 2020? I kind of expect they would more likely have you do a Riemann sum. Okay, but who knows? All right. You can certainly, you get to use a calculator if you want, so you could certainly figure this out pretty easy. The second base is from 5 to 9, so that's a base of 4. And you're going 40 plus 24 over 2, so the average height of that. What's the third base from 9 to 11? It's 2. And so the average height, 24 plus 68 over 2. And then finally, the last base is from 11 to 12, so only one. It's a skinny trapezoid. The height is 68 plus 18 over 2. So you'd want to use a calculator to put all that together, but once you do, you'd get 345.5. Okay, but you have to explain the meaning, all right? And the meaning is that 345.5 cars leave the parking lot and just if you go back to the original problem, all right, it says that the day begins time 0 is 5 a.m. So time 2 would be 7 a.m. Okay, so 7 a.m. And then add 10 hours to that to 5 p.m. So 345.5 cars leave the parking lot from 7 a.m. to 5 p.m. You could probably put from time t equals 2 hours to time t equals 12 hours and they wouldn't count off, would be my guess, but who knows. All right, and then part D is another accumulation problem. It won't be on the test. I'll go ahead and explain it real quick, but it says $5 are collected from each car entering the parking lot from time 0 to 6, $8 from time 6 to 12, so how many total dollars? So that's actually, it's too bad it's not on there. It'd be a pretty easy one. So from 0 to 6, you get $5, so 5 times E of T, plus you get $8. I guess that's the higher usage time from 6 to 12 of E of T dt. And you get to use your calculator on that, and you get $3,530 and 16 cents, but that's not on the 2020 test. So really part C is the one to study, and part A also, at least look over it. So part A, look over it, you won't have to do a derivative that hard, and then part C is one you absolutely need to know how to do. All right, let's move on. We're going to move on to number 3. Since there was so little in part 1, I'll go ahead and put 2 problems on this video. Okay, number 3, I think the possibility exists that all 4 parts. So we have a function. It's a piecewise function. So got the square root of 9 minus x squared for when x is between -3 and 0. And then negative x plus 3 cosine pi x over 2 and that is from 0 to 4. Okay, so part A says find the average rate of change between -3 and 4. The average rate of change is the slope of the secant line. So that's going to be f of 4 minus f of -3 over 4 minus -3. So you just take the 2 endpoints, y2 minus y1 over x2 minus x1. Okay, so we've got to figure out what f of 4 is. It's a little bit of a pain. So that'll be negative 4 plus 3 cosine 4 pi over 2. So that's 2 pi. All right, so cosine of 2 pi is 1, so it's negative 4 plus 3, which is negative 1. And then f of negative 3, we would have to use the top equation, right? So that's the square root of 9 minus 9. So that is 0. So the slope, f of 4, is going to be negative 1 minus 0 over 7, which is negative 1/7. So that is the average rate of change between negative 3 and 4. Absolutely could be on the 2020 test. I'd be surprised if you didn't have one like that. Okay, let's see if we can squeeze in part B. It says write an equation for the tangent line at x equals 3. So you know your tangent line equation, y minus y1 is equal to the slope times x minus x1. So we've got to get the slope by taking the derivative at 3. We have x1 because they gave that to us. It's 3, right? And then we need to get y1 by finding f of 3. So f of 3 would be this second equation, right? Because 3 is in between that interval. So it's negative 3 plus 3 times the cosine of 3 pi over 2. Well, the cosine of 3 pi over 2, have that unit circle ready on the test, but the cosine of 3 pi over 2 is 0. So that's going to be negative 3. So we've got our y1 value. Now we need to get the slope. So the slope is going to be f prime of 3. So let's get f prime of x. We're going to take the derivative of this second equation, right? So that's going to be the derivative of negative x is negative 1. The derivative of cosine would be minus sine, right? So negative 1 minus 3 sine pi x over 2 times the derivative of the blop here, which would be pi over 2. Okay, so f prime of 3 is going to be negative 1 minus 3 times the sine of 3 pi over 2 times pi over 2. So what is sine of 3 pi over 2? It is negative 1, right? Have that unit circle ready. So that's negative 1. Negative 3 times negative 1 would be plus 3. Right? Negative 1 plus 3 times pi over 2. Okay, that pi over 2 is out here. Negative 1 plus 3 pi over 2. Okay, so that's the slope. Don't worry that it's kind of fancy. Just write it like that. So our tangent line equation is going to be y minus negative 3. That's plus 3 is equal to the slope. I'm going to put that slope in parentheses. Negative 1 plus 3 pi over 2 times x minus 3. Hey, you can do that. All right. You know, not super duper easy, but doable. Okay. I wouldn't worry about shooting that 3 over to the right side. You can if you want, but you know, make them count it wrong. Okay, pause if you need to. I'm going to erase all this. Okay, let's look at part C. It says find the average value of f on the interval from negative 3 to 4. Okay, so this is a good problem. I think this problem is a little bit harder than what you'll get, at least part of it. But the average value, you absolutely need to know this equation. It's 1 over b minus a times from a to b of f of x dx. Okay, so we've got two different equations here, so we're going to have two different integrals. So 1 over b minus a, okay, so we're going to end up having 1 over 4 minus negative 3, okay, times, and then it's going to be, here, let me put this in brackets. Okay, that's this part. We've got two integrals. So we've got from negative 3 to 0 of the square root of 9 minus x squared dx, plus 0 to 4 of negative x plus 3 cosine pi x over 2. So if you can just get this part, you're getting partial credit, all right? You set it up right. Now, I'm going to tell you this value, integrating the square root of 9 minus x squared, that is not a U substitution problem. And I think that this is a little harder than one they're actually going to ask you to do. Okay, so, but I will tell you if they will give you one you can do by hand, but this one, that answer from negative 3 to 0 is 9 pi over 4. But I do think they could give you one of this difficulty to do. So you've got 1/7, 1 over 4 minus negative 3 times 9 pi over 4. And then let's integrate, go ahead and integrate this part. So the antiderivative of negative x is negative 1/2 x squared. The antiderivative of cosine is sine, right? So you'd have 3 sine pi x over 2. And then we're going to need a 2 over pi, all right? So times 2 over pi. So let's take the derivative of that real quick. So that would be 3 cosine pi x over 2 times 2 over pi times pi over 2. So that those two would cancel out. All right, you could do a U substitution there if you wanted and have U be pi x over 2 and go through it that way. All right, so and then we're going to evaluate that from 0 to 4. So that's going to be negative 1/2 times 4 squared plus 3 sine. Plug in a 4 and you'd have 2 pi times 2 over pi. And then if we plug zeros in, you're going to end up getting all zeros on the second part of that integral. So, all right, that is going to be sine of 2 over pi is also 0. So look at that, that's a lot of zeros there. So all you have on this part is negative 1/2 times 16, so negative 8. So the average value is going to be 1/7 times 9 pi over 4 minus 8. I think you'd get a lot of partial credit if you could just set that up, even if you mess some of this up. All right, so that is part C. Again, finding the average value of something, having to integrate. I'm not talking about the average rate of change. All right, average rate of change is slope of secant line. Average value of something having to integrate is fair game for the 2020 test. All right, let's look at part D real quick. Part D comes from early in chapter 2, so absolutely fair game. I can see him trying to see if you understand this. So it says, must there be a value x that attains an absolute maximum on the closed interval? So part D, we want to know, on that closed interval, negative 3 to 4, is there a max? Well, because it's closed, you can have a max potentially at -3 or 4. The point that would cause this function to not have a max is where there could be a break in the function, and that's at 0. We want to know, is there a break in the function at 0? Or is there a discontinuity? To do that, you take the limit as x approaches 0 from both the left and the right side. All right, so the limit as x approaches 0 from the left of 9 minus x squared. Just plug in a 0. That's going to be the square root of 9, which is 3. And the limit as x approaches 0 from the right of negative x plus 3 cosine pi x over 2. Okay, negative x, negative 0 is 0. Cosine of 0 is 1, so that's going to be 0 plus 3 times 1, right? This would be 1. So that's 3. So these two are equal. So it's continuous. Okay, so you could have a max at either endpoint, maybe or maybe not, but you could. And since it's continuous at 3, there's no break, then this function is continuous. So the answer is this. According to the extreme value theorem. So that's one you haven't really seen. A continuous function on a closed, all right, meaning it's got brackets here, it's that less than or equal to. If it's open, you can't have a max or min on an open interval, at least at the endpoints. On a continuous function on a closed interval must have a maximum. So the key terms there I underlined: extreme value theorem and the fact that it's a closed interval. All right, that's all I have for today's video. Especially number 3 is a useful one to study, and then part C on number 1, very useful to study. And I'll talk to you next video.